Hello, we're going to take a look at some multiplication property of exponents here. And before we dive into it, we want to define a couple of vocab terms to be sure we know what we're talking about here. So, a blank is a number, a variable, or the product of a number and one or more variables. A monomial. A term you've probably heard thrown around, but a monomial is just a number. So it's a product of a number and one or more variables. So a 5 would be a monomial. 5 times x would be a monomial, because there it's a number times a variable. 5 times x times v would be a monomial. And then way out there, 72 times y times z squared times a to the third would also be monomial. So notice all my exponents are positive, no negative exponents. They're all integers, my exponents, all integers. And then it's a string of multiplication. As soon as I go to something like this, that is not a monomial. That plus sign, or if it's a minus sign, splits it up into two terms, and we then go and call this a binomial. So monomial only has terms connected by multiplication. Well, what about a constant? Is a monomial that is a real number. So that's just a special type of monomial. A 5, a 6, a 12, a 15. Okay, so that's a constant. If there's no variable attached to it, we call it a constant. And again, that's a word you've heard thrown around quite a bit, I'm sure. Which expression is a monomial? A. Alright, we're done. Oh, okay, fine. We'll go back, take a look at this. Which expression is a monomial? So B, notice it is split up with subtraction right here. So that becomes a binomial, so that would not be a monomial. Right here, we have division. And once again, monomial only involves multiplication, because actually, this could be written as x, y to the negative 1, so there you have a negative exponent. Negative exponent is an idea we talk about later. Same with this right here, we have some division. So this is the only monomial going on there. Okay, what about this multiplication properties now? The first one, product of powers. To multiply two powers that have the same base, add their exponents. Okay, key thing, base. So if I am multiplying two numbers and they have the same base but different exponents, I can just add those exponents. So kind of multiplication turns into addition is one way to think of it. B to the third times b to the fifth equals b to the 3 plus 5, or b to the 8th. Notice we have the same base. That big number down low is the same, a b and a b. Okay, so a letter standing for a number there. I could have over here 3 to the 5th times 3 to the 8th. Okay, my base is the same, so that would equal 3 times 5 plus 8, or 3 to the 13th, and you could put that in a calculator and find some really big number, or just leave it as 3 to the 13 for our purposes. Simplify. 5x squared times 4 to x cubed. So this is multiplication, so let's not forget that what we know about normal multiplication, and that is we can go 5 times 4 gives us 20, and then x squared times x cubed would be x2 plus 3, which is 20x to the 5th. So notice I multiplied my numbers. I multiplied kind of the common terms, the like terms together. 5 times 4 gave me 20. X squared times x cubed, which is x to the 5th. And it looks like b is our number. So as far as exponents go, multiplication turns to addition. Okay, can we simplify this guy? Here we have number and two different variables. Again, multiply, because it's multiplication in between here, multiply the like terms. So you got 3 times negative 2, negative 6. X times x squared. Bases are the same, so let's add our exponents. Remember, there is, if you just see an x, there's kind of that implied one, x to the first power. So this becomes x to the 1 plus 2, or x cubed. And then y squared times y to the third, y to the fifth. Add your exponents. And going down the list, does D match up? Looks like it. Okay. That's our product of powers property. But what about power of a power? The real strong one. Power of a power. This guy, he gets big real quick. That is because when you take a number with an exponent to an exponent, you multiply the exponents. Okay? 3 to the fifth, if I raise all of that to the second power, I now have 3 to the 10th, because it's 5 times 2. So when you have a single monomial and you raise it to a power, you multiply the exponents. So their exponentiation goes to multiplication, whereas before we saw how multiplication went to addition. Simplify. 4 squared, squared, cubed. Did that make sense what I said? Probably makes sense if you just kind of look at what's written here. So that property applies even if we're taking it to the power a couple times. And sort of use your order of operations and work inside out. So 4 squared, we're going to leave it like that. We're not going to evaluate that to 16 yet. But we'll go 4 squared squared. So that would be 4 to the 4th. And now that is being cubed. And there I'm taking a power to a power. So 4 times 3 is 12. So 4 to the 12th. Okay, so C is our answer. Slide over here. And we will simplify negative 2xz squared to the 4th. Now because we have these parentheses here, all of that is being taken to the 4th power, sort of including that negative. So let me write this split up to see what's going on. We have negative 2 being taken to the 4th power. We have x being taken to the 4th power. And we have z squared being taken to the 4th power. Negative 2 to the 4th, that's negative 2 times negative 2 times negative 2 times negative 2, gives me positive 16. X to the 4th, because that's just sort of x to the 1st to the 4th power, so 1 times 4. And then we have z squared to the 4th, z to the 8th, because I multiply my exponents. Capiche? Capiche. So, combine them. I'll do one last problem here where we kind of combine both of our properties. This idea of simplifying an expression is pretty key, because a lot of problems you're just going to be asked to simplify this expression. So 3 bullet points to know when it's simplified, because you might do something and then be like, oh, am I done? But maybe it's not simplified all the way. You might have to do 3 different steps until it's totally simplified. So an expression is simplified if each variable base appears exactly once. So if I have, like my variables 8, a, b, c, each of those should appear only once. I don't want something like 8, a squared, b to the 3rd, a cubed. That would not be simplified because I could combine my a's. There are no powers of powers. So if I have a cubed squared, that's not simplified because I should take that power to the power. All fractions are in simplest forms. So if I have 2/4 a squared, I should write that as 1/2 a squared. Okay, if all 3 of those are fulfilled in these exponent problems, your expression is simplified. And as we simplify this guy right here, we're going to keep in our mind the order of operations. So we're going to work inside out. So I'm going to start on this guy. All of that is being squared first. So that 2, that exponent 2 right here, kind of distributes to all 3 of them. So I have 8 squared, g to the 6th, h to the 8th. Exponent to an exponent, so you multiply. All of that is being squared. And then it's times 2g h to the 5th, 4th. All right, now I'm going to bring in this square to all 3 terms, distribute that. So I have 8 squared squared. That would be multiplication, so it's 8 to the 4th. G to the 6th squared, 6 times 2, so that's g to the 12th. And then h to the 16th. All of that multiplied by 2 to the 4th, g to the 4th, h to the 20th, because that would be 5 times 4. Power to a power. Okay. Now I have multiplication going on, so if the bases are the same, that means I can add the exponents. Now look on this first one. The bases are not the same because I have an 8 and a 2. So don't go 8 to the 8th or 2 to the 8th and just add the exponents. Instead, we should simplify each of these numbers. So I have 4096, g to the 12th, h to the 16th, and then 2 to the 4th, which is 16. Now that they're numbers, do what we did earlier where we're just going to multiply the numbers, multiply the like variables, and we'll go from there. So 4096 times 16, whopping big number, 65,536. G to the 12th times g to the 4th, add your exponents, g to the 16th, and then h, 16 plus 20 is 36. And this should be our final answer right there. Simplified because all the variables are combined, no power of a power, all fractions are simplified. And those are our multiplication properties of exponents.